I worked on a project for diagnosing diseases based on the symptoms. The data set is published publicly on Kaggle, and actually it's based on the voice of patients, but there is no need to do a speech to text because it's already done, and it's provided on the Kaggle. First, I wanted to use sklearn, a library which is in Python language, just to build, basic pipeline and use basic models, classic models, and do some just minor text mining. So I loaded the data, and it says that it has around 7,000 samples with 13 columns, and only some of them are numeric, which means that others are object type. Here we have a sample of the data set, and the symptom text is in phrase column, and the classes, which is the diseases, are in prompt columns. First, I built a model based on just the text of the text, and see how the model works. And then we can add other features from the data set, or we can do some feature engineering and use extract other information from this column. For example, length of the sentence, or we can use other techniques like part of speech tagging, and there are many other techniques. But first, I just wanted to build a model based on the text without even doing any, removing stop words or punctuations, just the raw text. I checked for the missing values to see if there is any missing values in the input column or the target column. Fortunately, this is a clean data set and there is no missing values. Then I checked the distribution of classes to see if there is an imbalanced class, and fortunately it looks good, and we don't need any oversampling or undersampling techniques to balance the classes. Then I split the data to test and train, and I use the stratify feature to make sure that the distribution of classes in train set and test set are equal. And I used TF IDF vectorizer to vectorize the raw text of the symptoms, and use a classic model, just a SVM model. And the result is really satisfying. I used precision recall and F1 score as evaluation metrics, which is good for classification problems, and the F1 score for each classes looks so good. There is confusion metrics, which shows that everything is good, except that some samples which were internal pain are classified as stomachache, and then I because everything is so good, I just finalize the model. And I trained it on the whole data, and we can save the model with pickle library or joblib, no difference, and then load it and classify a random text. So, as I said before, the data set is so clean and good, and there is no need to use any sophisticated techniques or use any language model, transformers, or even there's no need to sentence tokenize the text.